All right, let's start today with the Ferris wheel problem. Algebra 2, going to be using sine and cosine functions, right? So let's say you're on a Ferris wheel, wherever you are. Maybe you're in Brooklyn on the Wonder Wheel, or maybe you're out in Santa Monica Pier and you're on the Pacific Wheel, or maybe you're on the London Eye, right? Doesn't matter. You're on a Ferris wheel. So let's get a clean page, draw a Ferris wheel, and then we'll do some problems on it. All right, let's get a problem here. Let's use black. Why not? We'll use black. So let's say you're on a Ferris wheel, and let's say the Ferris wheel right over here, the Ferris wheel is 80 feet in diameter. All right, so right away we can, we'll just make a Ferris wheel. Try to make one anyway. There's our Ferris wheel. And if it's 80 feet in diameter, we know it has a radius, as our center point, has a radius of 40 feet. But again, we have to hold up this Ferris wheel too. So let's say it's going down and it's being supportive. Not supported, but supported. And let's say we have a little support there. And let's say there's a stairs. We have to have a stairs to get up. Stairway to heaven. And let's say that stairway, from the ground to the stairway, let's just say it's 5 feet. So you got to climb 5 feet up. So now we know that if it's 5 feet up and we have a radius of 40, the diameter is 80. We know now the top of this Ferris wheel, when you get to the top here, you're looking out 85 feet. Because we have to include the ground 5 feet up. And we also know that the midpoint right here, even though the radius says 40, we also include the 5 feet from the ground, so the midpoint would be 45 feet. And we know we're starting at 5 feet, so we have that so far. So let's go back to the question. The Ferris wheel is 80 feet in diameter, and it makes one revolution. That's the period, by the way. One revolution is the period. And let's say it does it every 60 seconds. So we know, let's change the color for a minute. Let's use white. So we know as it's moving this way up, and it goes here, up, then it goes down, then it goes down, and makes one cycle, one period, one revolution in 60 seconds. So we can look at this on the graph, right? So if we have our graph here, and we have our x and y graph, and this will be the time graph, x, time t, and this will be the function h of t, the height. What is the height at a certain period of time? So we're starting here at 85. We have 45. Well, not starting at 85, but we have 85, 45, 5, and then we have 0. So you can see that at right here, when you get on the stairs, right here, you're starting at 5 feet, and you're going up. Now let's put a dash at the midpoint. The midpoint is 45 feet. And we're going up at a certain amount of time. So that'll be one of our first points there that we can divide up. So again, if we compare it here, we're going up, and over here, we're going up. And then we're going up again. We're going up to 85 feet. Cutting through our little definitions there. We're going up. And then here we went up, and here we're at the top here, and we're at the top here. And then we go down, and we're going down. So there's another point. Let's make them in red, the points. Why not? Bring them out. There's all our points we're making. Of course, you can make many points. And then we went down, and we went down again. And then we'll put a point there. So this point right here, this was at time 0. And this point will be at time 60, because that's the full cycle, the full period, right there. So we can say then at this point here, when we got to the top, since it is the halfway point, we can say it's time 30. And then we can cut everything else. We can cut this point right here, 15, because that's halfway between 0 and 30. And halfway between 30 and 60, we have 45. So we have, and we could put many points on here. So we know when we got to the top of the roller coaster, well, the Ferris wheel, not the roller coaster, top of this London Eye or wherever we are, we know that it took 30 seconds to get there. So we can make an equation from this. Well, first of all, we want to know, are we using cosine or sine? You can use either one, right? So we'll use cosine, right? Because it looks like an upside down cosine. So let me show you that. So, and why don't we use, I'll stick with red. So we can say the function of h of t, the height, will equal, and we're going to say, we want to know A is going to be the radius or the amplitude. And the amplitude is the radius. You can see the radius is the height from this midpoint up. And we know the height is 40 feet because that's what the radius is. So the radius is the amplitude. So now we can say h of t equals, and since we're doing an upside down cosine, remember, cosine will start from here and go this way, but we're doing it the opposite, so we're going to say negative. And the amplitude we said was 40, so we're saying negative 40 cosine. That's what we're using, cosine. And we have our parentheses here. Okay, and then we're going to put the midpoint here, which we said was 45 feet. So you put the midpoint here, the amplitude here, or the radius, and then use cosine or sine. Now over here, we're going to use k over t, k times t. And k equals 360 degrees, which is the degrees of a circle, divided by the period, the cycle, the revolution. We know it's 360 divided by 60 because we said 60 seconds right over here. And when you get that, you know that k is 6. So we have 6t, and we just created our equation. Now, if you want to see if you're right, what will happen at t is 0 when you start? So plug in on your calculator, negative 40 cosine times 0, because 6 times 0 is 0, plus 45, and you get 5. So if you plug in wherever you want to be on this axis, whatever time you want, you plug in the time for t, and you'll get where you are, how high off the ground you are at a particular moment in time. And that's how you do the Ferris wheel problem. All right.